Hello everyone, in this video you'll learn about some problem solving regarding to standard reduction potential values. We're going to start with finding out which one is stronger. If you are given a table like this containing the half cell reaction, and when you look at all of the reactions in here, all of them are in the reducing form. Okay, they are all being reduced because they are gaining electrons. So all of them are gaining electrons. Therefore, the reaction that we are seeing now on your screen, this is reducing. So the value that you have in there, the E0 value that you have in here on the right hand side of the table, those are the standard reduction potential value. So when the question asks you which one is the strongest reducing agent, you do remember reducing agent will get oxidized, because if you are the reducing agent, you will get oxidized. So if you are getting oxidized, you will be at the anode of the galvanic cell. So the question says that which one is the strongest? So we need to find the strongest reducing agent. So we need to look at which E0 value that is the most negative. When you look in the list, the most negative is right here. So that is the most negative. So the reducing agent that we are looking for is that. Okay, so the answer will be Ca solid. Why? Because it has most negative E0. When you look at this question, now it wants you to find which one is the strongest oxidizing agent. So this is the opposite of what we had over here. Still, when you look at the E0 value given to you, you still have in reduced form. All of these half cell reactions are for reduction. Okay, you have the SRP value over here, and you need to find the strongest oxidizing agent. Oxidizing agent is the opposite from reducing agent. So if you want to find out the most negative E0 for reducing agent, to find the strongest oxidizing agent, you have to find out the most electropositive E0 value. So when you look in the table, the most positive would be that one. Okay, so that has the most positive E0 value. So the oxidizing agent we're going to look at is this. Okay, so you're going to go to the other side. So you have CO3 plus aqueous. Why? Because it is the most positive E0. Okay, so remember, oxidizing agent will be the one getting reduced. Okay, getting reduced at the cathode. So between CO2 plus and CO3 plus, which one is getting the electron? CO3 plus is getting the electron. So that's why this one is going to be the oxidizing agent. You're not going to write this one because CO2 plus is losing the electrons. Okay, the one over here, the reason why we write Ca solid as the answer, calcium solids as the answer, because we want to find out the strongest reducing agent. Reducing agent is getting oxidized. Oxidation is losing of electrons. So calcium will need to lose the electrons. So that's why the answer will be calcium solids for reducing agent. So these are all the reducing agents, and these are all the oxidizing agent, because these are the one going to be reduced, and these are the one that going to be oxidized. Now we're going to look at the second type of problem solving regarding to standard reduction potential values. In here, we're going to try to find the standard cell potential, E naught cell, standard cell potential, using the formula we have over here. E naught cell equals to E naught cathode minus E naught anode. We have two formulas to find the standard cell potential, but for the sake of simplicity, we can use the formula of E naught cell right here. We have a question. In this question, it says that the galvanic cell consists of a magnesium electrode immersed in its electrolytes and silver electrodes immersed in its electrolytes and connected by a salt bridge. What you need to do for this particular question, you have to calculate the standard cell potential. So we need to find the E naught cells. And what is given to you in the question gives you the SRP value for magnesium half cell and SRP value for the silver half cell right there. Okay, so the yellow bits, that is what the question wants. Okay, so the question wants you to find the standard cell potential, and the question gives you the SRP value. So this is the symbol for SRP value, standard reduction potential value, for magnesium half cell and for silver half cell. So the first thing we need to do is we need to use the formula of E naught cell equals to E naught cathode minus E naught anode. Note that we have the word cathode and anode, and we have two SRP values given to you, and you need to identify between the magnesium half cell right there and the silver half cell right here, which one of them will be at the anodes and cathode. Okay, do remember, more negative SRP value will be at the anode. We have magnesium half cell, negative 2.36 volts, silver half cell, positive 0.80 volts, E naught cathode, E naught anode. So between magnesium and silver, which one will be the anode and cathode? Obviously, the magnesium half cell will be your anode. Okay, so this one will be the anode because the value of SRP is more negative, and your silver half cell will be the cathode. So we're just going to simply plug in the values inside, and we'll get E naught cell equals to, okay, the value of cathode right there is 0.80 minus volts minus, and we have negative 2.36 volts for anode, negative 2.36 volts, and the final answer should be positive 3.16 volts. That is the final answer. You'll get 1 mark for the equation, for the formula, and 1 mark for the final answer. Don't forget to put the positive sign to show that this reaction over here is spontaneous. Okay, So you have a spontaneous reaction. Let's have a look at the second question for this type of problem solving. Given to you the standard reduction potentials of silver ion and iron 2 ions. We have silver ion, so when you look at the reaction, okay, I'm just going to highlight that for you. Look at the reaction over here. Both of them are at reduction form, okay? So you have this reduction form, and the question says that these are the standard reduction potentials. Okay, so these are the SRP. And do remember, more negative SRP will be the anode, and more positive SRP value will be the cathode. The question wants you to find the electromotive force, okay? So the word electromotive force over here is the same as E naught cell. So if you see this terms in your questions or in examinations, it refers to the E naught cell, okay? So the standard cell potential. So we want to find the electromotive force for electric cell and determine whether the iron solid will be able to reduce. You want to know whether this iron over here will be able to reduce Ag plus aqueous to Ag solid. Okay, so first thing, we need to use the E naught cell equals to E naught cathode minus E naught anode. And when you look at the E naught value over here, the one that is more negative right there and more positive right there. So the one that is more negative, this one will be the anode, and more positive will be your cathode. Okay, we're just gonna simply put the value inside. So the cathode will be 0.80 volts minus, okay, you have minus over here. Puts the brackets, you're just gonna write the value exactly, negative 0.44 volts. And the answer would be plus 1.24 volts. Okay, so for the next question, it says over here, determine whether this iron solid will be able to reduce Ag plus into Ag. So the word reduce refers to the reduction, okay, whether it will be able to be reduce the Ag plus into Ag solid. So since the E naught cell value is positive, okay, Fe will reduce Ag plus ion to Ag solid. So that is the answer. So in exams, you will be able to get 1 mark for this, 1 mark for that, 1 mark for this statement, 1 mark for that one. Okay, so since the value over here of E naught cell value is positive, ion solid will be able to reduce Ag plus ion to Ag solid. And another reason why, when you have this value over here, this is what we say as a spontaneous. This is a spontaneous reaction. The third type of problem solving related to standard reduction potential values is when the questions want you to identify whether the reactions are spontaneous or non-spontaneous reaction. Typically, the questions will ask you in this form. They will ask you whether the reaction takes place spontaneously. So you are given the overall cell reaction, and you should be provided with the SRP value. Okay, in here you are given with the SRP value, and the first thing you need to do, step number 1, is you need to split this overall cell reaction into two, into anode and cathode. And that is quite easy. So we're going to do it one by one. So first we try to do Cr solid and Cr3 aqueous first. Okay, so step 1, I'm going to highlight that over here. So you're going to do Cr solid, and what happened? You'll get Cr3 plus aqueous. And if you look here, you have 3 plus, and to balance this, we'll have to put plus 3 electrons on the product side. And we'll do for CO3 plus, cobalt 3 plus aqueous. So we're going to have it 3 CO3 plus aqueous. And you are going to be having on that side 3 CO2 plus aqueous. And to balance this, you have 2 plus over here, you have 3 plus over here, and to make that 2 plus, we'll have to have plus 3 electrons, because you have 3 and then you have 3, then now it is balanced. Okay, and then when you look at both reactions, based on what you have in here, you have to identify which one is going to be the anodes and cathodes. Okay, so step 2. So which one is going to be the anode and which one is going to be the cathode? Anode, okay, anode is oxidation, losing electrons, the one above. Cathode is reduction, reduction is gaining electron, the one in here. Okay, so we're gonna have the anode. Okay, step 2. So the anode would be your losing of electrons. So you have Cr solid, you have Cr3 plus aqueous plus 3 electrons, and at the cathode you're gonna have 3 CO3 plus aqueous plus 3 moles of electrons, 3 CO2 plus aqueous. And then in step 3, Okay, I'm just gonna do a boundary over here. In step 3, you are gonna be using E naught cell equals to E naught cathode minus E naught anode. And right now, your anodes is chromium half cell, which is right there. That is the SRP value, so you're going to plug it in there. And your cathode is going to be your cobalt, so the SRP value is right over here. Okay, so we're going to substitute the value inside. So you have equals to, so the cathode is cobalt right there. So you get plus 1.82. Sorry, I'm just going to write 1.82 volts. Okay. Minus, and your anode is chromium half cell. So that is the SRP value. So you're going to have negative 0.74 volts. So when you solve this, you will be able to get positive 2.56 volts. So is this spontaneous or non-spontaneous? So you're going to write here, since E naught cell is positive, the reaction is spontaneous. Okay, so you have a positive value over here, so the reaction is spontaneous. So you'll get 1 mark for this, 1 mark for that, and 1 mark for the statement you're going to write over here. Okay, and also over here, sometimes they're going to give you 1 mark, sometimes you don't have it, but it's important for you to know that to solve questions like this requires step 1, 2, and 3. Let's have a look at another one. Okay, so again, you are given with the SRP value. Okay, so these are the SRP value. And step number 1, you have lead over here, so I'm just going to write Pb2 plus aqueous, and on that side you have Pb solid, so you're going to plus 2 electrons to become Pb solid. So this is based on the reaction that you are given over here, and you need to identify whether it is spontaneous or not. And we're going to do for bromine. So you have 2 Br minus aqueous, and on the other side here become bromine to liquid. So that is bromine to liquid plus 2 electrons. So we're done with step number 1. We have split the reactions given over here into 2 based on what you have there. And then in step 2, we have to identify who is the anode and who is the cathode. Remember, anode is oxidation, cathodes is reduction. Reduction, red cats, reduction. Reduction is gaining of electron. So the one that is gaining electron is lead. So we're going to write it over here. Pb2 plus aqueous plus 2 electrons. Gaining of electrons. Then you get that, reduction. And then at the anode, you have the 2Br2 aqueous, Br2 liquid plus 2 electrons. So that is the losing of electrons. You have your anode and you have your cathode identified. Okay, then step 3. We're going to use our very, very useful E0 cell formula, E0 cathode minus E0 anode. Now, your cathodes is lead, half cell, and your anodes is the bromine half cell. So we're going to take the value as it is, as they are been given right there. You're going to plug it in right here based on the identification, anodes and cathodes, based on the given reaction that you have. So the cathode, okay, the one in purple is lead. So the value for lead is right there. So you have negative 0.13 volts minus your anodes is right here. Okay, for that one, you have 1.07 volts, and therefore the value is negative 1.20 volts. So you have a negative value. So you're going to write over here, since the E0 cell is negative, the reaction is non-spontaneous. Okay, so the reaction given to you over here is non-spontaneous because the E0 cell value is negative. So you'll get 1 mark for that statement, 1 mark for using this formula, 1 mark for finding that one, and that 2 steps over here are also important.